It's happening everywhere, all the time. In your car's engine as you drive to work, in the massive factory that built your phone, even inside your own body. It's the science of rubbing, an invisible force that's one of the most critical and most expensive phenomena in our entire world. Take a good look at this number, 23%. Any guesses what this could be? Maybe the efficiency of a new type of solar panel, the portion of the internet that's just cat videos. Well, the reality is, it's something way, way bigger. That's right. Nearly a quarter of all the energy humanity generates is basically thrown away just to overcome things rubbing against each other. It's like this massive invisible tax on everything we do, and we pay for it with wasted fuel, worn-out parts, and lost power. So the big question is, how do we fight back against this invisible drain on our world? Well, believe it or not, there's a whole field of science dedicated to it, and it has a name you've probably never heard before: tribology. It comes from the Greek word tribos, which, get this, simply means I rub. So it is quite literally the science of rubbing. It's the whole study of how we can manage friction and stop the wear and tear that slowly grinds our machines to a halt. And you know, the field was basically born from an economic wake-up call. Back in 1966, a report by a guy named Peter Jost showed that friction was costing the UK's economy over 1% of its entire GDP. All of a sudden, this science of rubbing wasn't just some academic curiosity. It was a major national priority. But of course, the actual study of friction is much, much older. We're talking Leonardo da Vinci sketching out its basic laws in his private notebooks way back in the 1400s. A couple of centuries later, Guillaume Montans published them for the world to see. It just took us another few hundred years to give it a cool name and realize how much money we could save by mastering it.
But tribology is the science. What's its primary weapon in this war against wear and tear? Well, the answer is probably sitting in your garage right now: lubricants.
And believe me, they have a whole crew of enemies to fight. See, wear isn't just one thing. It's more like a gang of different destructive forces. You've got adhesive wear, where surfaces literally get sticky and rip chunks off each other. Then there's abrasive wear, which is like sandpaper in your engine from the inside out. And on top of that, you've got fatigue and corrosion. Each one is just a different path to machine failure. And the difference this stuff makes is just night and day. On the left, you could see what happens to unprotected bearings. They're just chewed up, pitted, and totally destroyed. But on the right, the exact same parts, but this time they were shielded by a high-performance lubricant. They look like they just came out of the box. That's the power of good tribology right there. And it's not just about the physical damage either. It's about heat. Friction creates heat, and heat is another machine killer. Just look at this thermal imaging. The gearbox on the left, using just some standard oil, is cooking at over 152 degrees Fahrenheit. The one on the right, though, with an advanced synthetic lubricant, it's just cruising along at a nice, cool 95 degrees. That's a 62-degree difference, and that translates directly into a longer, more efficient life for that machine. And the hard data tells the exact same story. In a standard industry test, they measure how much metal is literally worn away from a bearing. The allowable limit is 30 milligrams. Now, a lot of competitive oils, they fail spectacularly, causing over 100 milligrams of loss. But the advanced synthetics, they can knock that loss down to just over 1 milligram. They don't just meet the standard, they absolutely blow it out of the water. Okay, so protecting industrial machines is one thing, but what happens when that machinery is making the food that ends up on our dinner tables? This is where tribology gets incredibly complex. I mean, really think about it for a second. You need lubricants that are tough enough to protect massive, high-speed equipment, but also so safe that if a tiny little drop gets into a batch of cookies, it's completely harmless. This is the central challenge. In these kinds of places, we have to deal with something called incidental contact. It's the small but very real possibility that a microscopic amount of lubricant from a gear, a chain, or a bearing could potentially find its way into the food that's being processed. And that's why we have food-grade lubricants. These things are basically engineering marvels. They're designed to do two critical jobs at once. First, protect the machine from destroying itself, and second, protect us, the consumers, from any harm. And as you can probably imagine, any product with that much responsibility on its shoulders is going to be subject to some incredibly strict rules and regulations. So the readings from NSF International are the ones to know. The most important one by far is H1. If you see an H1 rating, That means the lubricant is certified as safe for that incidental food contact we were just talking about. H2 is for lubricants used in places where there's zero chance of contact, and H3 is for other things like cleaning oils. But H1 is really just the starting point. Think of it this way. H1 certification is like checking the recipe for a cake to make sure all the ingredients are safe to eat. Super important, right? But the gold standard, ISO 21469, is way more comprehensive. It's like having an inspector watch the entire process, how the ingredients were sourced, how clean the kitchen is, how the final product is handled. So if a lubricant has that ISO 21469 certification, you know it's already passed the H1 test and then some. It's the highest benchmark for safety. So how much is a trace amount anyway? Well, the U.S. Food and Drug Administration, the FDA, has a very, very specific number in mind. 10 parts per million. That is the absolute limit. To put that in perspective, that's like 10 seconds out of 11 and a half days. It's an incredibly tiny amount. And on top of that, the lubricant has to be a total ghost in the machine. No color, no odor, and no taste. And hey, here's a quick mythbuster for you. A lot of people still think the USDA is the agency that approves these lubricants, but they actually stopped that program way back in 1999. Today, it's independent organizations like NSF International that run the certification programs that help keep our food supply safe. So, from massive industrial gears to the factory that makes your lunch, this hidden science of rubbing is absolutely everywhere. But let's zoom back out and remember why this matters on a truly global scale. Remember that crazy 23% of the world's energy lost to friction? Well, researchers have found that by applying the advanced tribology we've been talking about, we could see huge savings. A 25% reduction in the transport sector, 20% in power generation. All told, in the short term, we could cut total global energy losses by 18%. And in the long term, the potential is just staggering. A 40% reduction in energy losses, which would mean global savings of nearly €1 trillion, not to mention a massive reduction in CO2 emissions. So the next time you hear a squeaky hinge, remember the unseen science of tribology, working quietly to make our world smoother, more efficient, and more sustainable. It makes you wonder, doesn't it? What other hidden sciences are out there, quietly changing everything?